Welcome back to Essential Foundations course on analytic idealism. Last time we've reviewed quite extensively analytic idealism itself. I've tried my best to explain it in depth over almost 1 hour and 40 minutes. It has been the most extensive video presentation I have done on analytic idealism specifically. So I hope that has been useful. In this part 5, we are going to review the empirical scientific evidence that seems to indicate analytic idealism to be the correct metaphysics and seems to contradict mainstream physicalism. I'm putting this very mildly. I think it would be defensible to say that we will review evidence that contradicts physicalism outright and makes it untenable and indicates analytic idealism very, very strongly. But you will be the judge of that, not me. As I mentioned last time, we are not going to review anything along the lines of paranormal research, not because it's not relevant, but because I think it's not necessary. Hardcore scientific evidence from laboratories around the world in the fields of neuroscience of consciousness and foundations of physics are more than enough to make the case I'm trying to make here. So let's go, let's start. Let's start with foundations of physics. Back in 2005 already, in July of 2005, physicist Richard Henry, a well-known physicist from the US, published an essay in Nature volume 436 of 7 July 2005. I'm going to link this stuff in the description of this video, so don't worry about that right now. He published this essay called The Mental Universe, in which he concludes that the universe is entirely mental. Matter is a kind of a prejudice. The universe is immaterial, mental and spiritual. Live and enjoy. He even used the word spiritual, which I personally wouldn't use because it's a very loaded word. But he derived this conclusion that he was brave enough to publish in Nature based on a number of experiments that have been going on for a long time. And since he published it, a whole lot of new experiments along the same lines were conducted. In 2007, 2010, 11, 13, 2015, and even more recently, there is a very important one in 2018 that I'm not listing here because it becomes too much. I will list them all in the description of this video. And all these experiments confirm what Henry had already concluded in 2005. And what they show is that physical entities, the things we normally call physical entities, like atoms, molecules, they do not have standalone existence. All the properties that we associate with physical entities are what in physics are called observables. And these observables, as shown by the experiments, do not exist prior to a measurement being made. In other words, the physical world is the result of an observation, of a measurement, which is very intuitive under analytic idealism. The dashboard is a set of measuring instruments. What you see on the dashboard is the result of a measurement of what's out there, the world as it is in itself. But the world that is in itself is not made of these physical observables. The world as it is in itself is the thing measured. So what the experiments show is that the positions of the dials on the dashboard, the physical observables, do not exist prior to a measurement being made. Of course, the dial will not show any value until you actually measure. And the conclusion is that matter, the physical world, has no standalone existence. It is an image, an appearance of something else. And that something else, the actual bottom level of reality, is not physical by definition, because what we define as physicality are the observables, the results of measurement, and those, again, do not have standalone existence. Now, these are very technical papers, very technical experiments, very difficult to explain in an accessible way to non-specialists. So what I'm going to do instead, we've produced a film at the Essentia Foundation, very professionally done, which tries to explain this in an accessible way in 3.5 minutes. So that's what I'm going to show you now, instead of trying to reinvent the wheel and explain it in a different way. So let's watch the film.
If two things are kept completely isolated from each other, they cannot influence one another, right? The world's smartest scientists are actually saying they can. We're going to do a little magic trick with these two. Alice and Bob. They both get 1/2 of a deck of cards. Alice takes the red cards, starts shuffling them, and gets on a plane. Bob stays behind, shuffling the black cards. On the other side of the planet, after an extra shuffle for good measure, Alice finally looks at the red card that's on top of her deck. What if I told you that the same black card is guaranteed to be on top of Bob's deck, despite the two of them having no contact whatsoever? Good trick, right? In fact, it isn't a trick. It's not magic. It's quantum mechanics. Science has shown this is what actually happens, not with playing cards, of course, but with the tiniest pieces of matter. If two material particles, say A and B, are shot in opposite directions, what one scientist chooses to measure about particle A instantaneously influences what the other sees when he observes particle B, even if the particles are at opposite ends of the universe. Imagine that. Simply looking at something at one end of the universe can directly influence something at the other end, with no material connection between the two. Scientists have taken every precaution you can imagine to rule out communication between the scientists or the particles A and B. No cheating, and yet the observation of one influenced the results of the other. This prediction of quantum mechanics existed for decades. Many physicists, Albert Einstein included, had their doubts about this wild theory, but a series of compelling experiments, starting all the way back in the 1970s, has shown it to be true. So what does this mean? Recently, we've reached an incredible conclusion. What we call the physical or material world has no standalone existence. Instead, it's just a superficial image in the mind of an observer of a deeper, mysterious reality. As such, matter only comes into existence upon being observed. It's not really there until you look. Yeah, try to get your head around that one. Not only our science, but also our culture and civilization at large stand to be fundamentally changed by this realization in the years to come. Perhaps this sounds far-fetched, but you can find out for yourself. You just have to look first.
All right. So how does analytic idealism then make sense of these results, of this instantaneous influence at a distance between two material entities or physical entities? Does it make sense of it at all? Or is analytic idealism equally discarded by these experiments, just as mainstream physicalism is? Because again, mainstream physicalism depends, it rests on the idea that physicality has standalone existence. It is the bottom level of reality, it's what exists. If physicality does not have standalone existence, then mainstream physicalism is out the window. Now, what about analytic idealism? Is it also out the window, or can it make sense of it? I will argue through a metaphor, a soccer game metaphor, that analytic idealism can very well make sense of these results. So the metaphor goes as such. Imagine there is a football game, a real football game. It's actually happening in the stadium. But you are not there. You are not in the stadium. You're watching the football game from home. You have a television. You choose the channel, a channel that is transmitting the football game, the soccer game. And you're watching it from home through a camera. So there is a camera in the stadium looking at the game through a certain angle and filming and transmitting it to your television. So what you see on the television is not the football match itself directly. It's not the soccer match directly. It is an image of that football match as captured by a camera. which is a kind of a sensor, a kind of an instrument that measures the actual soccer game. So the actual soccer game is here, and these are appearances, these are images on the television screen. Now imagine that you have two television sets, and in the other television set that you put next to the first, you're watching the same match, but through another channel. There's another channel, another broadcaster that is broadcasting the same match using different cameras. Each broadcaster has a different set of cameras. So you see the match now from another angle. That's what I'm trying to illustrate here. This is one angle, this is another angle. Images captured by different cameras of the same soccer match, the same underlying reality, the match itself. Now, these are images here on the first TV set. On the second TV set, these are images as well. Now, the images are completely correlated with one another. Of course they are correlated. They are images of the same reality, of the soccer match, the thing that actually exists. But these are images captured by different cameras using different camera angles. So the images are different, but they are correlated. So if something happens in this image, like the ball moves this way, then something different will happen in the image below, such as the ball goes that way. You see? Now, it is the same ball here in the stadium. It is the same soccer match, but you are observing that underlying reality through different camera angles. In other words, you get different images, but correlated images, such that a change in one image instantaneously, quote, affects a change in the other image. Now, do the televisions affect one another? Is there causality between the television sets? Of course not. There is just an illusion of causality. It looks like if this ball moves that way, it causes that ball to move that way. No, it causes no such a thing. Why? Because these are not real. These images are not the world, are not the soccer match in and of itself. They are appearances thereof. Both are different extrinsic appearances of the same one underlying reality, which is the soccer match. Now, you do not have direct access to the soccer match because you're not in the stadium. All you have is an instrument panel, namely two television sets. These are your instrument panels. So is it surprising that changes in one image correlate perfectly with changes in the other image and instantaneously? No, it's not surprising at all. You don't need the televisions to talk to one another for that correlation to be there, because these, again, are only images. They are only appearances. They are not the reality of the soccer match. They are images of the soccer match. So how do I link this metaphor to what's actually happening? Well, I'm sure you already understood it. The physical world, what we call the physical world, is the dashboard. It's the images on the television sets. Quantum entanglement, the spooky action at a distance, is only the correlation between the two images. The two images are correlated because they are both images of the same underlying reality. But that reality is not accessible to us because we only have access to the dashboard, to the television sets. We are not in the stadium. We do not have a transparent window into the world as it is in itself. All we have are the measurements, the observations done by the instruments in our dashboard. And these measurements and observations correlate beyond space-time constraints. Why? Because they don't need to communicate via space-time. The communication is not between the two images. The communication is between the reality of what's happening and the measurements that are performed of this reality. You see? That's the point. So, to understand what's going on, we have to stop thinking about images, about televisions, what's on the television, as if it were the soccer match itself. It is not the soccer match. The physical world is not the world as it is in itself. The physical world is a representation, an appearance on the screen of perception, on the dashboard of dials. Physicality does not have standalone existence, standalone reality, for exactly the same reason that the images on the screen do not have standalone reality. You want to prove that? Turn off the lights in the stadium, and these images would disappear. If they had standalone reality, the images would still be there, even if you would turn off the lights on the stadium. But they don't have standalone reality, because they are not the thing in itself. They are not noumenal. They are phenomenal. They are appearances, extrinsic images of an underlying reality that we do not have direct access to. So I hope I've repeated myself enough to drive the point home. The key point is that what appears to us as very confusing and unexplainable results becomes trivial, completely understandable if we just drop these inherited assumptions of mainstream physicalism. If we just drop the notion that what is really out there is the physical world. It is not. The physical world is a television image of something that underlies it, that is hidden behind it. Just like the real soccer match underlies, is somewhere hidden behind the television. The soccer match is the substance, is the ousia. The physical world here on the television screen are just images. Just images. They do not have standalone reality. If we stop expecting the physical world to be the thing in itself, to have standalone reality, we will suddenly realize that there is nothing really so extraordinary about the results coming from foundations of physics over the past 40 years. Experiments that have been now repeated so many times in such refined ways as to close all possible, imaginable, conceivable loopholes that we cannot deny the results of these experiments anymore. Now, the alternative to giving up mainstream physicalism and adopting analytic idealism, the alternative to that, based on these results, is the following. It is to postulate that countless gazillions of real physical universes pop into existence every infinitesimal fraction of a femtosecond, for which there is absolutely zero, precisely zero, empirical evidence. Now, you take your pick. Either gazillions of universes popping up every infinitesimal fraction of a femtosecond, for which there is no empirical evidence, precisely zero, or the physical world simply does not have standalone existence. It's an image on the dashboard of dials that evolution has provided us. And what's really out there is not physical, it is mental. Now, you take your pick. Use your reason, use your sense of plausibility, and you take your pick. I've taken mine. Now, a completely different line of scientific results in neuroscience of consciousness. There is a number of studies pointing to the same thing, so let's go through them one by one. An extraordinary set of results emerging from research on the psychedelic state began in 2012, began with this paper from the Imperial College London. For the longest time, we assumed that the way psychedelics produce this incredibly rich and intense hallucinations would be by sort of lighting up your brain like a Christmas tree to cause these hallucinations, because we thought brain activity somehow is or generates experience. So if you had incredibly rich and intense experiences, then you have to have a lot of brain activity that correlates with that inner experience. But this study showed precisely the opposite. Under psilocybin, cerebral blood flow, which correlates with brain metabolism and therefore brain activity. When I say activity, what I mean is metabolism, the level of metabolism in different brain areas. What happens to metabolism is that it decreases. The blue areas here show decreases in brain activity in the psychedelic state compared to placebo. Notice that there is no increase anywhere psychedelics only decrease brain activity. And this result has now been repeated not only for psilocybin, but for LSD, for DMT, a number of other psychedelics. The results have been confirmed by a number of research groups in different universities, different countries, different continents, and they are surprisingly consistent. Psychedelics only reduce brain activity, brain metabolism. Now, how do we then explain experience? Well, it's at least very uncomfortable, very tricky, very difficult to explain experience based on the assumptions of mainstream physicalism given these results. Because if experience is brain metabolism, how can experience increase and brain metabolism decrease at the same time? So I think for reasonable people who are not married to a particular metaphysics, the conclusion here that we can take with some degree of confidence is that, okay, that mainstream physicalism is off the table. Now, how does analytic idealism accommodate this? Because you see, there is a sense in which analytic idealism follows mainstream physicalism in that the dissociated mental activity within an alter should also correlate with the brain activity, because brain activity is what the dissociated inner mental activity looks like when observed through a brain scanner. We've talked about this in part 4, in the previous module. However, there is one extra element under analytic idealism. You see, the process of dissociation itself should also have an image. It's not only the contents of the alter that are bound by we see we have an alter here, and there are mental contents inside. Now, these mental contents inside should correlate with increased brain activity under analytic idealism, just like mainstream physicalism. But some of these processes in the alter correlate with the process of dissociation, with the dissociative boundary itself. Because dissociation is not nothing. Dissociation is a process. It's a doing of nature. Nature is doing dissociation. So the dissociative process itself should also have an image. But if the dissociation reduces, that image will be a reduction in brain activity that correlates with the dissociative process itself. In other words, some reductions of brain activity under analytic idealism should correlate with a reduction of the dissociation itself. That's the point. So, under certain circumstances, for instance, the use of psychedelics, the brain activity that is reduced largely seems to correspond to the dissociative process itself. And if that brain activity is reduced, then dissociation is reduced. And if dissociation is reduced, what was an impenetrable dissociative boundary may become a porous dissociative boundary, not perfect anymore. This porosity will correlate with the reduction of certain types of brain activity. And if the dissociative boundary is porous, now mental activity that was beyond the boundary can go in and be experienced non-locally. So to say, I postulate to you that this is probably what's happening. Psychedelics directly affect the dissociative process itself. The image of that, when measured, is these reductions of brain activity. And the person has an enormous increase in conscious experience, much richer, much intenser conscious experience, because experiences that were not in the alter now can percolate through the porous dissociative boundary and be, well, experienced. So in a psychedelic trip, you are not experiencing the contents of your alter, which is what we normally do, our own thoughts, our own imagination, our own feelings. During a psychedelic trip, brain activity reduces, signaling that the dissociative boundary has become porous, and what we experience are transpersonal things that just percolate through the boundary. And those will not be registered in the image of the alter, because again, although I'm drawing them going into the alter, this is a spatio-temporal drawing. What's happening is that you're picking out if this is your outer, you're picking up things that are actually not within the boundary of dissociation. And this may be the case not only for psychedelics, but for other instances of so-called paranormal phenomena like telepathy, clairvoyance. This is speculation. But speculation as it may be, it is more promising speculation than trying to reconcile this with mainstream physicalism. So the question then is, how are physicalists trying to reconcile these results? I'm showing only one paper. I'm going to link a whole bunch of them in the description of this video. How do physicalists try to reconcile these results with physicalism? They use a notion they call diversity or brain entropy. Now, this is just a nice, beautiful, very technical sounding word for randomness or noise. That's what they're talking about when they talk about diversity or brain entropy. It just means brain noise, random activity in the brain. And what they managed to show is that the noise level, the randomness of our brain activity in psychedelic states increases. It increases in a statistically significant way. Now, so what? Is this a good explanation for the phenomenology of the psychedelic experience? The trip, what we feel during the trip, is it a good explanation for that under physicalist premises? No, it's something I would even be ashamed to put forward if I were a physicalist, because it just defies plausibility, it defies logic. But yeah, that's the degree of despair that the mainstream physicalism now has. And let me explain to you why it doesn't explain it. Let's begin with the obvious. A psychedelic experience isn't random. If you really take a psychedelic in a high enough dose to go through the first little effects that have to do with phosphine and, explainable, easy stuff, but you pass that and you go into the actual trip. The trip is not random. It's not random noise. A psychedelic trip is highly structured, highly symbolic. It's not only rich and intense in a random way. No, it's rich and intense in a surprisingly structured way. Most trippers with experience would tell you that it's much more structured than our ordinary experience of the world. It seems to be higher dimensional. It seems to be more compelling. So how can an increase in noise in the brain account for a much richer and intenser and more structured experience than ordinary reality? It doesn't seem to add up. But that's not all. If you look at the effect, let's look at the effect. I'm showing here on this side of this picture, which comes from a paper trying to make sense of how psychedelic experiences, how psychedelics create the trip. They show the result for 3 psychedelics: psilocybin, which is the active ingredient of magic mushrooms, ketamine, and LSD. And the white dots correspond to the psychedelic post-drug injection, and the black dots correspond to placebo injection. So it's a comparison between placebo and the psychedelic. And the comparison is the level of randomness, which they call diversity in a very romantic, technical way, the level of noise. And the conclusion they extract is that, look, post-drug is a little higher than placebo. The noise level increased a little bit. Here as well, post-drug is a little higher than placebo. Drug a little higher than placebo. For ketamine, the same. Drug a little higher than placebo. Here too, drug a little higher than placebo. And for LSD, drug a little higher than placebo in all 3 instances. But look at the bloody scale. Look at the scale. In a scale from 0 to 100, the average increase in noise level in the brain of the psychedelic compared to placebo is 0.005. This is not a small effect. It's a tiny this end. In fact, is it statistically significant? Yes, it is statistically significant. They have enough samples that even such a tiny difference can be argued to be statistically significant. But does it explain the phenomenology? I don't think it does, because the richness and the intensity of my experience under psychedelics is not only 0.005 in a scale of 0 to 100 higher than my ordinary experience of the world. It's a lot more than that. So do you see the level of, I would say it's the level of desperation that neuroscience of consciousness now is in to try to make sense of results that, on the face of it, simply contradict mainstream physicalist assumptions, to try to make sense of them under physicalist assumptions. They are basically ignoring everything else and trying to find a story that holds some water. If you ignore everything else, like if you ignore how tiny this effect is, and moreover, for several of the placebo drug pairs that they had, the effect went in the wrong direction, which you may say, well, statistically it goes in the right direction. Yeah, right. But in some cases, people had the trip and the noise level in their brains actually reduced. And that ignores that noise cannot possibly be an explanation for the phenomenology of the psychedelic experience. Now, is that all? No, that's still not all. You see, you cannot eat the cake and have it too. If you say that in a psychedelic state, experience is explained by a piece and tiny increase in the noise level of brain activity, in the randomness level of brain activity, then all experiences should be explained in the same way. You know, if my eyes are closed and I'm seeing nothing, I should have less brain randomness than if I open my eyes and listen to music, because the explanation for experience is the degree of brain randomness. So more experience should entail more brain randomness. You should apply the same rationale for everything, not only for psychedelics, because it defies belief if you put forward that there are two completely accounts of experience under physicalist premises. That under psychedelics, it's the noise in the brain that creates experience, and under ordinary conditions, it's the metabolic level of the brain that creates experience. I mean, you can't have both. You can't have the cake and eat it too. So, if this is going to be the explanation on the physicalist premises for the psychedelic experience, what about experiences that are not psychedelics? Well, we have decades of literature showing that under ordinary conditions, experience correlates with an increase in brain activity, an increase in metabolism in the brain, not in brain noise. For instance, we now got to the point, look at this paper here, which I will also be linking in the description, that we can train AI algorithms to read the patterns of brain activation of a dreaming person. And based on a training, which is done with a person awake, looking at an image on the screen, so the AI knows which pattern of brain activation correlates with seeing that image. If you do that with enough people, the AI learns which patterns of brain activation go with which kinds of experience. And then they hook up a person sleeping, dreaming, to a brain scanner, and they read the patterns of brain activity of the dreaming person, and the AI now knows how to translate that into a description of the dream, and we get it right. You know, we now got to the point that if a person is dreaming of looking at a statue, I mean, could there be a more bland, boring, non-intense, poor experience? It's hard to imagine an experience more poor than just staring at a statue. But the AI has been able to correctly tell that a person was dreaming of looking at a statue just by looking at the patterns of brain activation. So when we dream things up during sleep, which is akin to a psychedelic trip, right? You can trip with your eyes closed. So these are all endogenous experiences, similar to imagination. So when that endogenous imagined experience happens during sleep, it correlates very well with patterns of brain activation. But under psychedelics, there is only brain inactivation and the noise level increases a tiny piece ant amount. You can't have both ways. It's either one or the other. You cannot adapt your physicalist explanation for experience depending on which study you have in front of you. That's not how it goes. Is that all? No. That's not all. Because we even know now that if you're having a lucid dream, for instance, of squeezing your hand, very boring, bland experience, right? Just squeezing your hand. That correlates enough with activation in your brain that researchers can tell that just by reading your brain activity. So, you know, it's one paradigm here and a completely different paradigm here. You can't do that. And even if that were not the case, you know, the effect is too tiny to account for the phenomenology. And even if you were not, the phenomenology is not noisy, it's not random, the phenomenology is structured. If that phenomenology, that experience somehow is brain activity or is generated by brain activity, you would expect structured experience to go hand in hand with structured experience, otherwise, structured brain activity. Otherwise, where is the structure of the experience coming from? From the spirit world, you know? So it is so ridiculously untenable what physicalists are now trying to make of these results to save their favorite hypothesis that it sort of raises the question, how do they get away with this? I mean, and I know the answer. They get away with this because our culture is incredibly prejudiced. We do not have enough theoretical imagination to conceive of a different alternative to mainstream physicalism. That's what Essential Foundation is trying to change, to let people see that there are actually very coherent alternatives to mainstream physicalism, which make sense of all this data. We don't need to push the envelope of plausibility to ridiculous territory as what's happening here. I mean, this is becoming comical now. It's on the edge of the ridiculous. I'm not dismissing the result itself, and it's nice to know that there is a statistically significant, although tiny, increase in noise level in brain activity under psychedelics. I'm sure this has some application somewhere, although I can't imagine it right now. So good, it's a real effect, it's statistically significant. Great, good for you. But don't try to pass this as an explanation under physicalist premises for the qualities of experience or the richness, structure, and intensity of a psychedelic trance. You're just making a fool of yourself for anyone who takes the time to actually read through the paper and understand it. Anyway, now, it doesn't stop with psychedelics. There is a broad pattern that shows that certain reductions of brain activity, which I hypothesize are reductions that are correlated with impacting the dissociative process itself, as opposed to the mental contents of the alter. It directly impacts the dissociation itself. There's a broad pattern of these things that go hand in hand with an increase in richness or intensity of experience, or with an enlarging of our sense of self. And this is what happened in this study from 2010, published in Neuron. I'm linking it below as well. They studied patients before and after the patients underwent brain surgery for the removal of tumors. And they scored these patients for what they call self-transcendence, which is a measure of what we identify ourselves with. Do we identify ourselves only with our thoughts, or with our thoughts in our body, or do we identify ourselves with something bigger, larger than our physical bodies, a larger part of the world than our physical bodies? So the higher the self-transcendence score, the higher it is here on this axis, the broader our sense of self. So they using a questionnaire, they scored these people for self-transcendence before and after surgery. And what you see is that after surgery, because, you know, you never remove a tumor cleanly, there is always some collateral damage that impairs normal brain function after surgery like this. That's why they call these patients lesion patients. Their normal brain anatomy and function has been impaired by the surgery. That impairment of ordinary brain function correlates very nicely and clearly, much more clearly than the noise level and a psychedelic experience. This is not a percent amount. This is not only statistically significant, it is a big effect, not a tiny effect. People with the lesions had a much larger delta, much larger increase in the self-transcendence score than people who did not suffer those lesions, people who did not suffer an impairment in ordinary brain function. And it's a very, very clear effect. Somehow damaging something in our alter mentality, and I would submit to you, damaging the dissociative process itself, causes us to regard ourselves as something bigger, larger than just the alter, something bigger and larger than just the body, than just our own thoughts and emotions. And that is significant if you're trying to get a hint for which one is the best metaphysics of nature from results like this. Now, is this all? No, I told you there is a broad pattern. I'm not going to discuss all of it with you here. I just sampled 3 of them to mention. This was a study, brain imaging study, done with people who self-identified as mediums, people who could go into a trance state and write down information that they otherwise shouldn't be able to have. Now, it doesn't matter whether the claim these people made about being mediums, whether that holds water or not, that's not the point. The point is they studied these mediums while they were in a trance state, instrumented with a brain scanner. They were in a trance state, writing down information that they claimed would come from a transcendent source. And they also studied with a control group, people who claimed they were mediums, but who the researchers themselves thought they weren't. They called them the less experienced mediums and the experienced mediums. That's politically correct lingo for non-mediums and people the researchers thought, something is happening with these guys here. And what you see is that in the trance state, the experienced mediums had reductions in brain activity in certain key brain areas that are involved in writing text, processing information and writing text. For the experienced mediums, there is a consistent decrease in all these areas of the brain. But for the control group, once they pretended to go into a trance state and started writing, there was a significant increase in brain activity in all the same brain regions. Now, this is what you would normally expect, because if your mind is engaged in writing text, the areas of the brain related to language processing, and syntax and grammatical structures and processing information, applying logic to what you are writing, those areas become more active. And that's what you should see. So it is confusing that for the experienced mediums, the activity went down. Now, but that's not all, because the most interesting part is that you can score text automatically. There are computer programs that do that. You can score text automatically for the level of complexity. Some text is very simple, use direct sentences, very few objects. Some text is more complicated. There are a number of sentences connected to the same point that you're trying to make. So you can score text for complexity, and more complex text should require more brain activity in the areas of the brain related to writing text. And what they found out, what they found out is that the experienced group, although the brain activity level went significantly down, their text scored for complexity scored significantly higher than the text written by the control group. Now, make sense of that under mainstream physicalism. Under analytic idealism, the explanation is the same that I hypothesized before. The trance that they put themselves in has to do with an impairment of the dissociative process itself. And it's that impairment that we see back in the brain scanner as a reduction of brain activity. There is something in that reduction of brain activity that is basically what a reduction in dissociation looks like under a brain scanner. And the text is more complex because, you know, you have a more porous dissociative boundary. So you're picking up on things that were originally not in your alter, things that actually don't belong in your alter. You're picking up things from the ether, so to say, picking up things from the world out there as it is in itself. Because the world out there, beyond the dashboard of dials, beyond the screen of perception, as we've seen, is made of mental activity, mental processes. And with a more porous dissociative boundary, you may be picking up on those transpersonal mental processes. Now, the list goes on, you know, hypoxia, which can be caused by partial strangulation or G-force-induced loss of consciousness, which happens when pilots are training in a centrifuge, or cardiac arrest. Hypoxia is consistently associated with richer, more intense inner experience. Even though you look like you have passed out, you look like you've lost consciousness because you don't move and your eyes are closed, but from within, your consciousness has just catapulted itself to the next level. We see that, for instance, in a dangerous game teenagers worldwide play, the choking game, in which they partly strangulate themselves because they've realized that they can get a high, like a psychedelic high, without the psychedelic. Now, it's peculiar, isn't it, that psychedelics produce their effect by reducing brain activity, and that teenagers happen to figure out that they can reduce brain activity just by cutting blood flow to the brain, and they also get a psychedelic trip. Now, this is not safe. This should not be done. Do psychedelics. Don't do this. Because if you do this, especially if you're alone, you may actually pass out and then not stop strangling yourself if you're using a rope or something, and you may die accidentally. And many teenagers worldwide have died because of this very dangerous game. G-Lock, we know from scientific studies that pilots that pass out during that centrifuge training report intense dreams. Now, how could that be? Blood has just been drained out of their brain, and they report experiencing intense dreams. So, think about that. A cardiac arrest, NDEs, same thing. Transcranial magnetic stimulation, which disturbs neuronal firings and reduces brain function, can lead to out-of-body experiences. That's also in the literature, and linking it below as well. Acquired savant syndrome, when people suffer brain damage because of bullet wounds to the brain, illness, physical trauma, being hit by lightning, being hit by a car, brain function is impaired, but suddenly they become geniuses in certain areas like mathematics, or geniuses of memory. They remember every single detail of every day for 30 or 40 years. Yeah, how do you account for that under mainstream physicalism? Generalized physiological stress, you know, the initiatory rituals of the world's pre-literary cultures, they all entail physiological stress. You know, you don't eat, you don't drink, you are stuck in a sweat lodge for 3 days, you have to go through exhaustive physical exertion. And somehow, according to those cultures, that leads to great insights about the nature of reality. Yeah, how come? Think about that. So the list is endless. I will link several papers on the description, but even that is not a complete list. So that's the evidence. So what we are going to do now is, again, review a 3-minute-long short film produced by Essentia Foundation that tries to summarize all this. Let us have a look at it.
Where are you? Where is your mind? Is it inside your body? Probably in your head, somewhere behind the eyes, right? It is commonly believed that our experiences are produced by this big organ in our heads, called the brain. But recent scientific evidence suggests something else. We've known that most experiences correspond to certain patterns of brain activation. For instance, computers can scan your brain and correctly guess what you're looking at or even what you're imagining. When someone is looking at an object, say a tree, we can see specific parts of the brain light up. That's amazing. It must mean that the brain generates our experiences, right? Not quite. No one in the entire history of science has been able to explain how brain metabolism produces the richness of experience we commonly refer to as the mind. perhaps it doesn't produce the mind at all. A new and vast body of evidence strongly suggests a completely different relationship between the brain and the mind. Here's the thing. Experiments show that certain reductions or impairments of normal brain activity correlate precisely with richer and intenser experience. Take drugs. Well, not literally. For decades we thought that psychedelic substances worked by lighting up the brain like a Christmas tree. Since 2012, however, experiments in respected institutions like the University Hospital Zurich and the Imperial College London have shown that the opposite occurs. You could have the most mind-boggling experience of your life while your brain effectively goes to sleep. And the evidence doesn't stop at psychedelics. Vietnam War veterans that had suffered brain injury were more likely to report rich spiritual experiences. Pilots undergoing acceleration-induced loss of consciousness, which drains blood out of the brain, report having rich dreams while seemingly unconscious. People who recover from a near-death experience regularly describe extremely rich, even life-changing sensations, even though medical experts know that shortly after cardiac arrest, there's almost no brain activity. Some people practicing meditation achieve rich trance-like states by using hyperventilation techniques that reduce brain metabolism. The list goes on. How is this possible? While it is undeniable that the brain and the mind are closely related, perhaps we need to fundamentally rethink what that relationship really is. Maybe the brain is not the generator of consciousness, but merely the image of a particular state of consciousness, less like a factory and more like a river. This alternative way of thinking may be hard to grasp, but it will determine the future, not only of science and philosophy, but of our very way of life. Anyway, that's where we are. Where's your mind at?
All right, and to sort of conclude this part, if you're not talking to people who are psychologically committed to mainstream physicalism, people who are no longer operating on the basis of reason and evidence, but have an axe to grind, you will see that there is increasing openness in our culture for alternatives to mainstream physicalism. And Scientific American, the world's oldest magazine in continuous publication, 176 years now this year, the world's most respected scientific magazine, they've published a dozen essays from me, and in each single one of these essays I make an explicit case against mainstream physicalism and for analytic idealism. And the editors were okay publishing this because they looked at the content. They looked at whether I could argue my case with substance and with reason and with evidence. And of course, is there a certainty that my essays are correct? Did they have that certainty? Of course not. They never have certainty about anything. Many things that have been published in very respected scientific publications have later been found to be incorrect and untrue. Does that mean that the publication was wrong? No, it's part of the research process. It's part of the learning process. But what has to be the case is that whatever you publish has to be well substantiated. Even if it later turns out to be wrong, it has to be well substantiated. And these guys have judged that what I'm putting forward is well substantiated. I don't think this would have happened 20 years ago. So we're slowly going in the right direction. All right, this completes this part 5. Now, in part 6, we are going to discuss an important distinction that is very often overlooked and which leads to all kinds of misunderstandings. And that's the distinction between phenomenal consciousness and meta-consciousness, or metacognitive consciousness. These two things are different, and to recognize the difference is important for us to find a place for the so-called unconscious under analytic idealism. Because under analytic idealism, there is only phenomenal consciousness, so there should be no unconscious. Yet we know that there is such a thing as the unconscious, the mental unconscious. So what's going on? Well, the explanation is that the unconscious is not really a lack of phenomenal consciousness. It's a lack of meta-consciousness, which is a subset of phenomenal consciousness. That's what we are going to discuss next time. So, once again, I recommend you don't jump to part 6 immediately. Give yourself a day or two to let it all sink in so you can see the world slowly through these new lenses. And then let's embark together in this important discussion about the unconscious in part 6. Till then, stay safe, and I'll see you soon.